Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague Dean Kinsella, one of our area engineers from the assessment team. Good evening, Dean. How are you? And how's your Monday been?
Good evening, Sam. Good to see you again. Monday, great start to the week. Doing assessments in North London. Had a full day assessment today with a great QS, great company. Knew his stuff. Everything was spot on. Had a good technical Q&A. Walked away there with a smile on my face, and hopefully he did as well. So it was a win-win for both sides.
That's brilliant. That's a good start to the week.
Yeah, brilliant. Yeah, can't complain. Hope the rest of the week's the same though.
Okay, so we'll start off this evening with our question of the week, which we posted out across social media channels earlier today. We'll go through our answer to that question. And then while you're putting your questions in the chat, we'll go through some of the questions we didn't get around to in the previous Q&A session last month. Please, while you're putting your questions in the chat, remember that there's no such thing as a stupid question, only stupid answers. And please remember to be respectful to each other in the chat, as the whole idea of this evening is that collectively we'll help each other with the overall aim of improving our collective knowledge and understanding of all things associated with BS 7671 and the world of electrical installations. So let's have a little look at our question of the week. So our question of the week that we posted out earlier today was, in a TT system, can I just use a circuit breaker to provide protection against electric shock? And we gave a couple of potential answers. One, no, never. No, it must always be an RCD. Yes, you can. Or lastly, yes, you can, but you must also use an RCD. So what's our thoughts on that one, Dean? Can we just use a circuit breaker for protection against electric shock?
Well, drum roll. For those who are already thinking about it, the answer is C. Yes, we can. So there's a regulation out there, for those who want to take a note, 411.5.2, and it states that obviously one or more of the following types of devices shall be used, the former being preferred, and it gives us two options: an RCD, and secondly an overcurrent protected device. So the answer is yes. There's a bit more information that we can go through for those who want a little bit more juice on it. There's also an informative note included within that regulation, which makes a statement saying that an appropriate overcurrent protected device may be used for fault protection, provided it is suitably low ZS is permanently and reliably assured. So you've got to guarantee you're going to maintain that low ZS value. Obviously, how to determine that is a different topic altogether. There's many different ways, but going back to that, yes. So if you have got a low value, it is permanent and it's assured to be reliable. The circuit breaker should be able to disconnect in the required time for the electric shock. Yes, you can use it as an RCD.
Yeah. I guess that the kind of situation would be if you had a building with a lot of structural steel, and then you were using the structural steel for your earth electrode, and it was because there was so much contact with true earth, your earth fault, your external earth fault loop impedance was so low, you could actually meet the ZS of an overcurrent protective device. I'm thinking that would be a kind of typical scenario where you could do it, and like you say, that's reflected in Reg 411.5.2.
Yeah, and like you were saying, that is one example where it is permanent and reliability is assured. You know, you've got multiple earth paths going to ground, you're going to have a great reading, you're going to meet your disconnection times. The chance of it changing, very minimal. So that's the sort of example that would give someone that reassurance that yes, I can use that, as opposed to a more standard, smaller TT installation where you may not be able to afford them ZS values.
Yeah. And so I guess the key the key words in what you said is it's a suitably low ZS which is permanently and reliably assured. That's the key bit.
Yeah, just one little bit that we just to bring to the table as more information which is coming from that particular regulation. Where an RCD is used for fall protection, the circuit also needs to incorporate an overcurrent protector device in accordance with Chapter 43. So it's not just the RCD alone. You've still got to provide a means of overcurrent protection.
Okay, so while we're hoping our audience fill up the chat with this week's questions, we'll take a look back on some of the questions that were held over. So first one is one that's common to the technical helpline. Can a new circuit be added to an existing domestic plastic, or as 7671 refers to it, all insulated consumer unit? So can I add a circuit to an existing plastic consumer unit?
So before I answer the question, I'm just going to say this topic comes up a lot during our assessments. I imagine it's not just me as an assessor alone in the area I cover, but this comes up a lot. The answer is yes. There's obviously criteria to meet to ensure that yes, some of which I'm going to go through now. The consumer unit still needs to be fit for purpose. Obviously still provides the appropriate degree of barrier and enclosure protection. That's the first one. All the existing conductor connections are correctly located in their terminals and are tight and secure as per manufacturer's instructions. Obviously no signs of overheating in and around the consumers itself. No incorporated equipment is subject to a product recall. So go on to the manufacturer's websites and other websites that I've got an affiliation, and just check that particular make and model has no recalls in place. And then what you've got to consider once you've looked at them is an actual requirement itself coming from BS 7671, which is 132.16, and it quite simply states, no additions or alterations shall be made to an existing installation unless it has been ascertained that the rating and the condition of any existing equipment will be adequate for the altered circumstances. So you must do your checks beforehand, your earthing and bonding and anything else that's relevant to that particular scope of work. Another point to raise once we've gone through that, depending on the additions to be made, the location of the consumer unit and the condition of the installation, it may be a consideration to recommend only upgrades in the consumer to a non-combustible enclosure. It's a recommendation only here. Providing all of the above are all met, then it would only ever be a recommendation and not a requirement. So all the aforementioned points that are raised need to be confirmed first. But it's always good to recommend to the client, but please be mindful, it's not a requirement. It would go down to a recommendation based on the aforementioned points.
Yeah, and so if, for example, it was in a sole escape route from, for example, a flat, if it was in an area of high combustion risk, then we might recommend it, even though it wouldn't be non-compliant to still continue and add the circuit. Okay, just following on from that, one of the questions that came in was about if we were to add a circuit, what's the best way to describe this on our installation certificate, and is there anything else we would recommend that they do?
Yes, so as always, the devil's in the detail. That's always the thing I say to my contractors. In that description, extent of the work covered and the installation, make it very clear what you are taking responsibility of. So be very detailed. That could be long-winded, clear and concise. Within that box on the extent of installation and the work covered. Additional circuit, give it a reference 1, reference 1L1, depending on if it's a single phase or a 3-phase board, is added to the existing installation, which contains insulated, put in brackets, plastic consumer unit. That would be a simple way, and put the word only on there. So that's all you've done, only. Kind of just push like a full stop at the end, that nothing else has been included. on top of the work you're already aforementioned. And then moving on from that, obviously on the same page, you should have the access to the comments on existing installation section. So it's important to get some information in there where relevant. And I do have this conversation a lot of times with my contractors about what's classed as relevant information. So what you will be in this situation, you will be mentioning in that comment on existing installation that the existing consumer unit is made of combustible material, in brackets plastic if it suits better, and maybe mention on top of that it was installed to an earlier edition of BS 7671 and it has been verified to be adequate for continued use. So you've made it clear in there that there is a departure from BS 7671 with regards to not conforming to the current standards, i.e. being non-combustible steel. And another point to raise with regards to certification when it comes to the inspection schedule items that were carried out is to consider making the right comments and ticking the right boxes within the inspection schedule item regarding the suitability of the consumer's IP and fire rating as NA, because it has not newly been installed as part of that scope of work. It is existing, and that's where a lot of contractors make their mistakes. They look at the whole inspection schedule items and they naturally assume that if it's appropriate and relevant within the installation, they should tick it. When it's relevant to the scope of work, that's why your description needs to be very clear and concise. The two of them tie in.
Yeah, no, spot on. And it is just about capturing enough information to make it clear what you've done, what was there already, and then the engineering judgment and checks that you've done to make sure that what was there already is adequate for the changes that you're going to make. We'll take one more. We've got some coming in, so hopefully we'll be able to start looking at tonight's questions. But one last one that was hanging over was, can a minor works certificate be used when replacing a circuit breaker for an RCBO? So we're not doing a like-for-like replacement, but we are changing a single protective device for one with different characteristics. In short, the answer is yes. That's a great example of where a minor electrical installation work certificate is acceptable for the certification of the work undertaken, because it's clearly associated with the replacement of a single protective device. So it would be considered an alteration, because now we've got different characteristics on our protective device, so it would be considered an alteration to the circuit, and therefore a minor works is fully appropriate. Would you add anything to that, Dean?
Not particularly. Again, what I would advise is to make it clear within the extent of the work covered exactly what you have done. So if anyone was to challenge it, the information is clear and concise, and it warrants that the appropriate certificate has been issued for the scope of work carried out.
Yeah, spot on. Okay, looking at the questions that are coming in on the chat so far. So the first one was, what code for an AC RCD on an EICR? So we're aware now in BS 7671 that it clearly states that AC type RCDs should only be used on fixed equipment where it's clear that there's no evidence of DC components being produced by the load. So it would straight away be considered as non-compliant in those situations for an AC. But one of the things I would say is we then need to consider, well, what's the RCD there for? And by that I mean, if it's there for additional protection and another protective device such as a breaker or a fuse is providing fault protection, then lack of additional protection generally would be recommended as a C3. If the RCD is there for fault protection, for example on a TT installation where our prospective earth fault loop won't achieve the required disconnection time with an overcurrent protective device, then we need the RCD for fault protection. If then we've got an absence of fault protection, we'd be looking at a recommended C2. So it really does depend on what the RCD is there for, whether it's additional only, in which case worst case scenario would be a C3. If it's for additional and fault, then worst case scenario would be a recommendation of a C2. Do you agree with that one, Dean?
100%. I'm just going to throw a regs number in there for those who want to take a note of it. 531.3.3 covers the types of RCDs, and at the bottom of note 3 for that, it does say RCD type AC shall only be used to serve fixed equipment where it is known that the load current contains no DC components. Yeah. So that's another consideration when you are doing your periodic inspection testing, is to have a visual look around, see what fixed equipment is in place, and see if it's kind of obvious if there's any DC components fitted to it. Some boilers might have some showers might have some. There might be other fixed equipment that may have some DC components within it.
Yeah. No, they're being more and more introduced, aren't they, by the things that we do. So even something as simple as a phone charger can actually generate a DC component into the AC supply. So yeah, it's worth consideration.
Yeah, just on another note, Sam, just very quickly, it's also worth the contractor being mindful that when they go to the wholesalers and they purchase a pre-populated board of some sort, that they do due diligence and check what type of RCD is fitted within the fuse board or the consumer unit, because it might be a stock item and it might not have been manufactured to Amendment 2. So it's always good having a quick look and just see what types of RCDs are fitted to make sure it's appropriate for the installation you're going to work on. Yeah,
no, good point. So yeah, before you leave the wholesaler, just check that generally, unless you've got that knowledge of the installation, we wouldn't be looking at installing ACs now, unless you can, as 7671 says, guarantee that it's a fixed load and there's no DC component. Another one is, if structural steel of a building is only accessible at the roof level, what would be the best way to determine whether it needs bonding or not? So it's a great question, and I'm thinking that, well, first of all, is it accessible? Because if it's not accessible, it doesn't need to be bonded because there's no risk. But if it is accessible, then we need to consider, is it simultaneously accessible with something else that would be at a different potential? So if, for example, the structural steel is the only conductive part that's accessible, then it wouldn't need to be bonded, because you wouldn't be able to, by touch, become the conductor between two different potentials. It only really needs to be bonded if you've also got access to another potential, and of course that may be, so you're going to need a good knowledge of what's there, a good survey of what's there, but I guess you could risk assess it out as not needing it if there was nothing else simultaneously accessible that would be at a different potential. Can you think of anything else on that? I'm just sort of trying to picture in my head a nice high-rise building with structural steel being exposed.
Yeah, I think if like what you're saying, you're just looking for that simultaneous contact, and even if, I suppose, if the only thing you did come in contact with was a conduit system or Class 1 light fittings, I'd like to assume only a skilled person would be working on or near them light fittings, then they would obviously isolate before working. If it was a non-skilled person, a risk assessment should still be carried out, and I can't see Santa Claus trying to climb through a roof, neither about a chimney being there, so he wouldn't be at risk.
Yeah, no. So it's, I think someone else later on has said that they'd always said any metalwork needs bonding if there's a risk of it being touched or accessible. But I think that's really only true if it can simultaneously be touched with another. If you know, if the only thing you can touch is extraneous conductive parts, they should be at the same potential. You could perhaps check that if they're connected to the same physical earth. But if there's no potential difference or no potential difference, for want of a better phrase, then I think you could legitimately document it as you've risk assessed it. But then that also talks about you know, if they do add something at a later date in that area, like Dean says, you know, they put an outside light, they put an outside socket, they use the roof as a means of taking a cabling system from one side of the building to the other, then whoever does that part of the installation would then need to consider bonding, because you know, under 132.16 he'd need to see that those extraneous conductive parts in his location would require to be bonded, because he's introducing different potentials.
Yeah, and just on what you were saying about that risk assessment, get something in writing to say that there's no simultaneous contact within that area, even support it with photographs, because what is now may not be the same during the next periodic inspection if any alterations or additions have been carried out. So as much evidence as you can to support that there's no simultaneous contact at the time of the inspection being carried out.
Okay. Another question's come in. Is there anything precluding extending a bonding conductor within an adaptable box with a connector block, then placing a safety do not remove label on the box, or does this joint need to be continuous? I can't find anything saying it needs to be, only when it loops from one extraneous conductive part to another. So yeah, there is a regulation that talks about it being continuous, so we always advise people not to cut and join bonding conductors from one extraneous conductive part to the other, on the basis that if the first extraneous conductive part were removed, because perhaps it was a water pipe or a gas pipe that the service provider removed, you could then lose your continuous connection to the second extraneous conductive part. So there is a regulation that covers that. On the basis of extending, I think we would recommend against it, on the basis that, you know, I was always brought up along the lines of every potential connection is a weakness and a potential point of failure. So we would always suggest that your bonding conductors to the extraneous conductive parts should be continuous. Perhaps a through crimp would be a better solution than an adaptable box with connector blocks in, because it would be seen as more durable.
Yeah, I suppose as a worst case scenario, if you can justify it or not, if it was commented and made a note of on any certification provided, and it was also given a designation of where to locate it for inspection and maintenance purposes, so that connection can be frequently checked for corrosion and any signs of you know, and if that's going to affect the low resistance that should provide.
Yeah. Okay. Another one that's common: meter tails longer than 3 meters. Do I need additional protection? So the 3 meter rule is one of those. It's an unwritten rule, because 7671 doesn't talk about 3 meters, but 7671 talks about your meter tails not requiring an additional fault or overcurrent protective device if the DNO agrees to the use of their protective device, their service cutout fuse, for example. And experience tells us that they will, providing you don't extend those meter tails longer than 3 meters. So it depends very much about the environment. Firstly, if you're doing a new install, then if you do extend them and you haven't got the DNO's written permission, then we would say it's non-compliant with 7671 if you haven't put your own protective device to protect those meter tails. So that's on a new installation. On an existing one, if you see that they're longer, then I think you need an engineering judgment as to what's the environment they're installed like. Are they suitably installed? So for example, are they double insulated? Have they got the required degree of protection for the environment and the usage that's going on in that location? And then you can record the fact that, or make that judgment, although it's non-compliant, is it unsafe? And it could be on an existing installation. For example, in a domestic situation, they might be longer than 3 meters, but because of the way that they've been installed, it might be non-compliant, but could still be considered safe for continued use on the basis that, for example, they might be double insulated, they might be an SWA cable, so it's got added mechanical protection. So little bit of a difference depending upon whether you're talking about a new install, in which case it would be non-compliant with 7671 if they were over 3 meters without DNO approval, and you couldn't attach that approval to your certificate. We would consider that non-compliant with 7671. But on an existing install, you need to think about, is it suitable for the environment? Is there any danger or potential danger to the users of the installation?
Yeah, and also make your description of your work carried out clear and concise, so you're not going to be wrote into you being responsible for the installation of the existing conductors where there might be a departure present. So it's, comment on existing installation, put a note in there, make your description of work clear and concise as well, just to back it all up.
Yeah. Okay, someone's also, one of the engineers asked, for new smoke or heat detector circuit being added to an existing installation, do I need to install SPDs? So SPDs would really be dependent on the environment, not the particular circuits. One of the things that the Corrigendum confirmed was that when Amendment 2 originally came out in 2022, one of the statements was that SPDs were required for safety circuits, and if you looked at the definition of a safety circuit, that definition would have included domestic smoke alarms. And in a nutshell, it was seen that we had a lot of organisations with large numbers of housing stock, so councils, social housing people, that had budgeted for an enhancement of their fire alarm and detection systems, only to find that 7671 Amendment 2 required those safety systems to have SPD protection. They hadn't catered for that, and then also it was found that if you used a reputable manufacturer for your fire detection and fire alarm equipment, they had some inbuilt protection against transient overvoltage. So that requirement was removed. That was one of the things in the Corrigendum, that was removed. So it would then boil down to the fact of the other two idents on that regulation. So is it in an installation where the potential loss of supply would result in injury or fatality, and is it in a location where the loss of supply would result in an intolerable loss of either financial or data? Is that about right? It's a while since I've gone back with that.
Straight at the regulation, okay. You've smashed that one, Sam. Yeah, it's bang on. Yep.
Okay. Another one. Are outdoor consumer units compliant when the MCB or RCD is not rated at low temperatures? And that's a great question, because we're seeing it now with particularly with EV, where people are putting standard domestic consumer units, either directly or in external enclosures, and it's something that needs to be considered, because we've got to take consideration of manufacturers' instructions, and in particular we need to confirm that our protective devices are still going to give us the degree of protection that we require. So it's a great question, and it's something that needs to be considered with your chosen manufacturer. So speak to your consumer unit supplier, your protective device supplier, to just confirm that this is now outdoors, and temperature ratings you're going to get a lot lower certainly in those winter months, which we're seeing now late in the year. And also possibly could get higher as well, depending upon where we are. So yeah, we haven't got a complete yes or no answer, but it's certainly something that needs to be considered, because one of our fundamental principles in 7671 says that everything we install must be suitable for the environment in which we install it in, or the way that we install it makes it suitable. So you've either got to put some kind of enclosure which will then make sure that things like temperature and ingress will allow you to have a standard domestic consumer unit, or you use a consumer unit that's specifically designed for that wider temperature range.
Yeah, I'm just having a quick look on one of the more well-known websites that provide circuit breakers and the likes, and they've all got that data within their website for you to have a look at and see what the temperature allowances are for the minuses and the pluses. So all the information's out there. You just got to do your checks, and if you can't find it on there, contact the manufacturer.
Yeah, but no, it's a great question, because we might see it as, oh, it's the same, we just need a little two-way board, but it's not actually, because it's a completely different environment. So it's a great question, and something that should be considered.
Yeah, relevance. Yeah.
We've got another one. How do you feel about the huge increase in outdoor domestic switchgear normally fed from the main head directly with no RCD protection to a metal enclosure at low level in an area accessible to children, and the risk of damage via impact, mostly with EV charging? Yeah, we actually did we did a small presentation at ELEX last week, and we'll be repeating it at other ELEX locations, specifically around some of the issues with EV charging, and this was one of them, in that we saw a lot of instances where people were using smaller cables to feed the EV charging equipment, and justifying it on the basis that there were overcurrent protective devices which would allow for smaller cables based on limited current, but a lot of people hadn't considered fault protection, so they were still relying on the DNO cutout fuse for short circuit and fault protection of those cables, and clearly the DNO wouldn't agree with using them if they were rated too small for the rating of the overcurrent protective device in the service head. So it was something that we picked up when we worked with with OZEV, the government department associated with the grants, and this was one of the things that we pulled up in the audits, where a lot of people had reduced cable sizes, not adequately protected, so things like tying them up with cable ties to the other main tails, so effectively they were actually putting strain on them, and it was a real no-no. So it's something that we're planning on doing a continuous article on, another article in Connections, because it's something that we came up with the top 5 reasons. We did a wire webinar on it back in the middle of last year, 2023, and that was one of the key points that it covered, that it was creating a real potential damage, in particular, like you say, when they were feeding an external metal consumer unit.
It's applying the right equipment for the right environment. You've got to obviously apply due diligence, and just don't always assume because something's been made in a certain way that it is suitable for all your environments,
Yeah.
contact the manufacturer, do your research just to protect yourself.
Yeah. What would you code an earthing conductor entering a metal enclosure in a separate hole to the tails? Yeah, so again, a common one, because we talk about 7671's got a regulation requiring that all the conductors on a circuit that should go through a ferromagnetic enclosure should enter through the same hole. So effectively there's no resultant current creating an eddy, or the possible creation of eddy currents within that enclosure, which could result in a thermal effect on the enclosure and possibly buckling, which could then put stress and strain on cables further entering. So it's non-compliant with 7671. It then, with regards to the recommended code, it would really boil down to is there evidence? Is there evidence of thermal damage? Is there evidence of buckling? Can we see that there's clearly a difference in the current flow resulting in eddy currents in the enclosure? If there is, and then you need to consider, is it having a detrimental effect? Is it making an unsafe installation? If it is, it would need to be quite large currents, and it would be very visible. So generally that situation we would suggest is a C3 situation, on the basis that it's non-compliant, but unless there's any evidence of an unsafe situation, then we wouldn't recommend anything further than a C3.
I totally agree. Yeah, spot on, Sam.
There's a few people saying that with regards to the 3 metre rule, that it's difficult to DNOs are non-existent to answer any questions, let alone 3 metre tails. Yeah, we understand and we feel your pain that that it is difficult, but document that, record your email response, record that you didn't get anything back, and then you'll have done your due diligence. Unfortunately, they have the upper hand, because 7671 clearly says they've got to agree. So if you haven't got evidence of them agreeing, then in reality it means that they haven't agreed. So it would then mean that you need to apply your own overcurrent protective device. You need to provide your own fault protective device if you can't get agreement to use theirs.
And also, if you've got a DNO enclosure, not to use the DNO's enclosure to install your own equipment in as well. Yeah. That's something that's becoming more of a discussion point as well, Sam, isn't it? Yeah. Again,
very strongly with EV, we find that people are seeing it as convenient, isn't it? The meter enclosure's outside. It might even be on the wall that you want to put the vehicle charging equipment in. So we've had instances where people have either put a small two-way consumer unit in the meter box, or in some instances we've seen they've actually installed the EV charging equipment in the meter box. And again, something that we covered recently is that although there's space in that meter box, it's not owned, that space isn't owned by the building owner. It's owned by the meter, the energy provider. And we are aware of instances where an energy provider turned up to install a smart meter. There wasn't enough space because other people had installed equipment in the meter box, and they gave the homeowner the direction that they needed to get that removed. Otherwise, the energy provider would remove that extra equipment and then charge the homeowner for that removal service. So yes, we were guided very heavily by ENA, the Energy Networks Association, who are effectively an organisation who represent all of the DNOs across the country, and it was under their recommendation that we guided everybody to say our recommendation, a strong recommendation: don't install anything in the meter box. Because you don't own that space, and neither does the building owner own that space. It belongs to the energy provider. just having a look at one of the others. IP20 rated ELV downlights out of zone in a bathroom ceiling. What would you code this? So ELV downlights out of zone in a bathroom ceiling. Well, Luminaire's 7671 does allow for equipment to be installed providing it's suitable for the environment, but I've just noticed, sorry, your question said IP20, which wouldn't be considered suitable for that bathroom environment. So I think then it's a case of, okay, it's non-compliant, but then is there any signs of water ingress? That will then also be factored by how long have they been there, you know. So is it a brand new install, in which case maybe there hasn't been any time for any ingress, so you would have to factor how long they've been there. But yes, you need to think about how bad is that water ingress. The fact that they're ELV you know, would give a degree of protection, but would the manufacturer guarantee that degree of protection with the water ingress as well? So that would sort of negate that. But yeah, very much so a good examination of the fittings to see just how bad the case is. But certainly you're looking at as I think our minimum recommendation there would be a C3, in that it's non-compliant, and then based on what you find during your investigation, it could actually be a C2 in terms of the potential danger. Because as I say, although it's ELV, which we wouldn't normally consider potentially dangerous for touch, but the fact that it may not operate correctly, i.e. you may not get ELV protection due to the fact of water ingress.
Just on that one, Sam, did the person that put the information out say it was outside of the zones or in a specific zone?
Oh no, yes, actually he said outside of the zones. So if it's outside of the zones, are we saying that it doesn't? So if it's outside of zone 2, if the bathroom's large enough, for example, then it wouldn't be a code straight away, but you would still need to look at the fact that is it suitable for that environment. So IP20, because although we might not get direct water splashing, we're potentially going to have a lot of humidity depending upon what the fan and ventilation of that room is like. So it would still be worth looking at, because it's a great spot actually, Dean. Although they're outside the zones, again, we talked about it earlier, didn't we, that everything should be suitable for the environment you install it in, or you make it suitable by the way you install it. So yeah, IP20 would look a little bit light in terms of protection against water ingress.
Yeah, I mean, signs of ventilation as well, isn't it? They've got a fan present. If the signs of any damp or condensation in the room will be a good lead towards any sort of IP ingress on them particular fittings. Yeah. So it would boil down to having a look at, you know, an inspection of the fitting to see if it is suitably rated for the environment it's installed in. Okay, we'll just finish on one last one. What should I do when I find that a TNCS system with a ZE much greater than the typical maximum of 0.35? So again, this is something that comes quite often into the helpline. So if on a new installation we got a measurement greater than 0.35, what would be our immediate advice, and what would we need to consider, Dean? So I'd be saying straight away, ask your customer, the client, to contact the DNO, or with their permission, you can do it on their behalf if they release certain details because they're the account holder. Inform the DNO of what value has been obtained, and request that they can visit the site to do an investigation on the issue. What you've got to consider is that the high ZE, depending on the value, it's the value that's given. It's not a maximum value. It's more of what the DNO sort of request as an ideal value, typical value, as opposed to the maximum. So what you've also got to be mindful of is, especially if it's a new build and you haven't put the supply in yet, base it on worst case scenario with what you've got. And if you think the value is significantly higher, then proceed with contacting the DNO to get further advice and ask if they can come out, and they will tell you if they are responsible for supplying a guaranteed earth path, or whether they'll instruct the client or the customer to get a contractor in to put sufficient earth in the ground, i.e. TT, and make sure the system is compliant with TT requirements.
Yeah, no, it was one of those. That was one of those light bulb moments when someone actually told me properly that the 0.35 figure for TNCS and in fact the 0.8 figure for TNS, they're not values that the DNO have to achieve. They're typical values. So don't be surprised sometimes if it's only slightly higher. The DNO may not even consider that worth coming out, but we always recommend worth recording it and reporting it, and then at a later date, if you can see that it is slowly increasing, then make that comment also to the DNO, because that could be an indication of a problem with the cabling in either the transmission or the distribution side of the business. So yeah, they don't have to achieve it, but if it's greater, certainly let them know. And if you've noticed that it's continually getting greater, it's increasing year on year or whatever time frame, then again make them aware of that. Bottom line is, if it is over 0.35, so long as that's not preventing you from achieving your maximum values for earth fault loop impedance, then you can still carry on and do your work knowing that you've got adequate protection against fault. So it doesn't prevent you from doing it, but yeah, as Dean says, give the homeowner, give the customer the information to report it, or if they're happy for you, do it on their behalf.
Spot on. It happens regularly. It's just having that understanding of what Sam said. But yeah, well done for spotting these things. It shows you're paying attention, you're doing the checks. Just hope it's at the start rather than at the end of the work being done.
Okay, once again we've run out of time, so I just want to tell you about a few things. The first one being we've got the next episode of The Wire coming up tomorrow night, Wednesday night, Wednesday the 6th. So if you haven't already signed up for that, please do go to the website and sign up for that next edition of The Wire. We're focusing this time on the importance of supervision and training requirements. So something that's newish to the electrotechnical industry, introduced a little while ago through the electrotechnical assessment specification, which is industry wide for all competent person scheme providers, including ourselves. So it'd be well worth looking at, and because we're finding that still people aren't recording necessarily what they're doing, but they are doing CPD as required. So yeah, it'd be really worthwhile signing up for that webinar. Either watch it live on Wednesday night at 8 o'clock or watch it on demand.
Yeah, but be particularly good for those who've NIC contractors who've got an assessment due up over the next couple of months, because it will help them to prepare themselves for what's going to be asked on the day. Yeah, very much so. Also want to make you aware of, please do stay in touch with us through social media, Facebook or X, Instagram, YouTube or LinkedIn. We will have another one of these, I want to say Monday night Q&As, because we do normally always do them on the first Monday of the month, but as next month April the 1st falls on a Monday, we thought we'd better not do it on a Monday, because yeah,
we weren't really prepared for what kind of questions we might get on an April the 1st Q&A. So we've shied away from that and moved it for the day. So next month we are still going to have a live Q&A that's open to everybody, but we've pushed it back a day to Tuesday the 2nd of April. So please do join us for that. Thank you very much. Some great questions and some great comments. Really good to see. I do apologise if we didn't get round to answer your question tonight, but I think there's 3 or 4 that we can take away, and we'll use those for the start of the next session. So thanks very much. Enjoyed that again tonight, Dean?
Loved it. I enjoy these so much because it gets you in touch with the way the actual contractors on the ground, their thoughts and feelings, what they're coming up against. And we want to be a part of that. We want to be able to help you as much as we can. We're not here to hinder, we're here to support. As Sam said at the start, we're working together as a collective. This is for everybody to benefit from. So the more people that come along, the more people that questions, the more answers we can give, and the more we can raise the standards within the industry. So thank you very much for everyone that's put time aside this evening. Yeah, brilliant.
Yeah. Wholeheartedly agree with that. Thank you very much. And sign up for Wednesday's webinar, and we'll see you again next month for another live Q&A. Thanks very much.
Take care. Thank you.